Okay, so let me welcome Adam, who's going to give our final talk in these sessions.
Thanks. Hi guys. Yeah, so as the title says, I'm going to talk about commercial data science for me and you, because it's a bit weird. This is probably the first time I've ever been asked to give a talk where someone says, can you talk about yourself? Just talk about yourself for a bit. But yeah, so I'm going to spend sort of half of it talking about my experience post-physics, why I left, what I did afterwards and what that was like, and then talk a little bit about industry in general, what sort of opportunities there are out there. So this is a 1 minute. I looked back at this slide this morning. I thought it's 10 years of my life in this one slide. That's a bit sad. But yeah, so 2006, I started a PhD in high energy physics at UCL with John Butterworth was my supervisor, who gave the plenary talk earlier today. I followed that with a postdoc because I enjoyed the PhD so much. In 2013, I quit and I worked at a company called Qubit as a data scientist. And as of 2016, I'm now working at the Economist group. So, I mean, I won't talk in too much depth about my time in physics because that's the part you all know about already. But just to give a little bit of context of where I was coming from, I was working on the LHC, on the Atlas experiment specifically. So I was an experimental guy. I spent a little bit of time out at CERN, living there, working on this kind of thing. Probably the most exciting moment was that I got to be on the Higgs discovery paper. See my name. This is on page 3 of 9 of the author list or something like that. But you know, I'm in there. It's not a lie. I did it. So yeah, my tiny contribution to that. So yeah, I mean, I guess the part that's interesting for you guys is to start to talk about why I decided to leave. I mean, when I was writing this, I thought, I definitely don't want this to be, I'm definitely not going to try and pitch either way here, right? You know, this is such a personal thing. So I'm just going to talk about how I felt at the time and what led me to make the decision that I did make. And I came to the end of my postdoc and, I applied for a few things. I actually had an offer of a postdoc job, and I got to that point where I had the job offer, and I thought, oh, I don't really want to do this. You know, I had this feeling that it was tough to access permanent positions. That even if I did a postdoc, it wasn't guaranteed that I'd be following that with a permanent position, and I was concerned that, yeah, I didn't really want to move around to follow postdocs. I had a partner at the time that I was living with and family all in London and friends and sort of a life. And I kind of thought, well, do I really want to move? Like, it's a big trade, right? You have to, I mean, sorry, Simon just to talk about how much he did that and how there were many positives. Of course there are, but it is a trade. I think you'd agree in some ways that it's a big decision to make. So I kind of thought to myself, well, okay, if I'm talking about making this really big, in some ways, sacrifice to sort of leave my life behind and go and pursue physics, I better really want to do it, right? Otherwise, this is a stupid thing to do. And I started to think a bit about what I actually wanted. What do I actually like about this job? I'm actually enjoying myself. And I am enjoying myself. But I sort of said, well, what do I enjoy about it? I realised that actually, I listen to some of my friends talk, and they talk about, the sort of these great historical figures in physics and the importance of the LHC in, the history of physics, the progression of the Standard Model over the last century, things like that. And that never really did it for me. I was always a sort of a day-to-day person. I enjoyed being there with the data and working on it and solving the problems and making the code work or whatever it was and finally getting the paper out. I enjoyed the activities. I realised that was my passion, was for problem solving, really, more than the physics itself. And so once I realised that, I thought, well, then this isn't a sensible trade for me to make to sort of change my life entirely around something when actually I should see whether I can find other jobs where I'd be doing these activities that I enjoy as well. So, I thought, well, what can I do? Okay, well, the LHC, if you're an experimental guy, then basically your experience is writing computer software to analyze extremely large data sets and making that run at scale on very large computing systems. And Also, sort of, I know this sounds a bit abstract to you guys, but maybe the transferable aspect of what we do in physics is taking a statistical view of data. We don't just pull numbers out of the machine and go, oh, six Higgses, there we go, we're done. You know, we ask all these questions like, well, what was our background? What were how well does the experiment work? What are the uncertainties? So we take this very robust statistical approach to data analysis. And that, and of course, if you're working in a large collaboration like I was, you have a lot of experience dealing with, you know, politics, right, and collaborating with people in big teams. So I looked around a little bit. I thought what was out there. I didn't really know what I was doing, to be honest. I thought, well, I'll just apply for some stuff, see whether I like it or not, because you know, you can't know. You're going to work in a completely new industry, and how can you possibly know what it's going to be like? You've got no chance. So I quite like the idea of working for a startup, because I looked around, there's quite a lot of data science jobs in consultancies, for example, and I thought that's going to be very corporate. That's going to be a bit of a jumping into ice cold water, a bit of a culture shock after the relaxed attitude of physics if I have to wear a suit to work every day or something like that. So I looked around, and you know, there's this sort of a bit of a startup scene in London, and I ended up applying for and joining a company called Qubit, who are a startup founded by 4 guys who used to work at Google and quit to set up this company. And they have a website which is targeted at marketers, which is completely meaningless to anyone who doesn't work in digital marketing in online retail. But basically what they do is they help online retailers who have websites with, you know, millions of visitors every day. They help them understand and interact with those customers. So they have, if you imagine that the analogy is that in a traditional bricks and mortar store, you might walk in and there's enough sales assistants there that if you have a problem, they can come and help you. The problem the online retailers face is, how do we make the experience of online retail more like that? You know, how do we know that there's a problem with our website? How do we know that people can't find what they're looking for? How do we know that it's confusing, we're not selling the products that they want? All of these sort of questions. And because everything digital is tracked, there's data, there's various companies in this space trying to help with this, and so I joined Qubit, which is in that area. So basically what I was doing here was they basically said, well, we collect all this data from retailers. We do a couple of things with it at the moment. One of the main things they were doing was something called A/B testing, which some of you might have heard of, but basically it means conducting a randomized controlled trial on a website to see whether something provides a better experience or not. And my boss said, we've got a sort of a research team. We're trying to come up with new stuff to do with this data that we think we can sell to retailers. So we want people who've got experience working with loads of data to come in and sort of help us out. And so he hired me. He quit immediately. Within the first month of me joining the company, he resigned. Which was it was a bit of a shock, because one of the main reasons I joined was I thought it'd be really good to work with someone experienced, you know, pick up a bit of knowledge about how it works. But it ended up working out because it gave me then the opportunity to sort of lead a small team in the end. You know, so yeah, I worked on things like A/B testing, mostly understanding how to apply machine learning and statistical techniques to very large data sets to do things like product recommendations. We had a product where people leave customer feedback, and obviously some of these websites, they might receive 10,000 pieces of feedback from customers every day. You know, no one's going to sit there and read that, so they want to be able to filter out automatically, what are people saying about us, what's important, what do we need to react to, those kind of things. And this is all, you know, machine learning, big data type analysis where, these kind of skills could be useful. So actually, I wrote a couple of notes here because I was trying to think back and remember what this first few weeks was like, because this in some ways for you guys is the most critical part of the process really. And I think the big difference is almost, it's more the culture than it is the work in some ways, I found, with what I did. Because that first week, you get sat down at a laptop and someone says, here's how you access our data. start trying to understand this for us. And, you know, if you're an experimental physicist in a big collaboration, it's basically the same, right? Someone says, oh, you know, here are our aggregate files from this run, and, you know, there's some problem with this. Can you figure out why this doesn't work, or how to apply this bit of software to it, or something like that? And, you know, so you're sitting there in the first week thinking, well, the data comes from somewhere different, but this feels very, very similar, what I'm being asked to do here. But the real difference is that it's different sort of people, really, right? You know, when you're in physics, every day you work with other physicists. They understand 99% of what your job is. You can talk technical terms, jargon. It's very insular. It's, you know, you're in the club. It's great fun in that way. Whereas if you go into the commercial world, people will look at you and they will be like, he or she's a genius. That person's like the smartest person I know, right? And they will look at you like you're mental. Oh, you understand maths. Wow, you know. And that has its pros, you know, and its cons. You know, the con is that now every time you go away and you're like, I've got this great idea, right? You know, we're gonna run this algorithm, we're gonna produce this, it's gonna be really useful. And you're gonna go into a meeting room with someone who probably got, you know, they didn't do very well in their GCSE maths, and you're going to explain to them why this is gonna help them. You know, why if we turn this into a product, you know, we're going to be able to sell this or something like that. You have to be way more communicative. I mean, I think a good analogy is if you've done outreach, you know, you're trying to explain things to a non-technical audience. But the pro of this is that, you know, you're exposed to many, many different ways of thinking, right? You suddenly have a complete overview of the process. And for me, working in a smaller organisation, and this is going to sound backwards to a lot of you who work in small collaborations and are thinking, well, if I go and work in a big company, it's going to be a bit more corporate, a lot slower. Whereas for me, going from Atlas that was about 2,000 people to joining a startup that was about 50 people when I started, we were a way more agile, like focused, fast-moving environment than I'd ever worked in before. So for me, that was really exciting that, you know, forget this sort of, well, we'll try this out, we'll start the simulations now, in 6 months they'll be done sort of thing, and then we'll do some analysis. This is like you've got an idea, well, let's build it, 2 weeks. Let's build a prototype, let's see if it works. All right, okay, we could be selling this in 3 months' time, right? Someone could be paying money for this. So it's a very different feel, very agile, fast-paced, and I really enjoyed that aspect of it, I have to say. So, you know, there's trade-offs. It's a very different experience. So I did that for 2 years. I joined, had some good experience, ended up managing a small team of people, and was quite happy doing it, really, to be honest. And then my boss, who resigned immediately, said, oh, I've just been at a conference with someone from The Economist, and their commercial part of the business, they want someone to come and do data science, understand their customer behavior, understand how they can use data to run their business more efficiently. And he said, I know you read it. So do you want to talk to him? I said, yeah, sounds good. Yeah. So about 6 months ago now, I joined The Economist. I almost don't want to say as much about this in some ways because I haven't been there as long. I haven't done that much in some respects. But yeah, I've always liked The Economist as a publication. So I guess a lot of people don't realise that obviously The Economist, there's about 100 journalists, 150 journalists, but the organisation as a whole is about 1,500 people because just like in a science experiment, you need to make it happen. It's not enough to have people to do the analysis. You need the people that print the newspaper and sell it and market it and all of this stuff around it. So here I work in the commercial part of the business. It's about understanding the customer, understanding how they use our products, but more generally than that, it's about understanding how you can take a very old legacy publisher, right, that has basically been printing a magazine that's essentially unchanged for 170 years. There is actually, it has changed a little bit. Apparently, in the Economist office, we have volume 1. And the only thing that is completely unchanged, if you ever read The Economist, is on the back page, there's the index, the prices. And way back in 1843, the first one has that, but it's like the price of cinnamon in India or something like that. This is the kind of thing they're covering back then. But so it's about publishing as an industry that's changing incredibly rapidly. Publishers have to adapt very quickly to be able to survive. A lot of people are struggling. The Guardian are bleeding money and things like that. So it's very important to be digital, to use data as effectively as we can to understand our customers, deliver new products, things like that. And my role here is kind of a bit strategic. I'm going to have to sort of build a team to do these things. So, like I said, in some ways, I haven't done that much in this job yet, so there's not so much to talk about. But I think, so I wanted to sort of segue from that into a bit of a general piece about, about sort of data science in industry in general. So I think you might say, well, like, do companies really need people who can do, PhD level physics to do some of these things? Is this really that hard, And I think, it's important for you guys. Most of you probably never worked in a sort of a corporate organisation, a sort of a commercial entity, and the way these places used to work, in the old days was the hippo, the highest paid person's opinion. You get some old guy at the end of the table and he goes, no, I don't care what you guys think. I don't care that you've got, you're working on this. I think our strategy should be we're gonna do this, right? And I think over time there's been a sort of a growing realization that that's not the optimum way to run a business, that actually there are many techniques from coming out of scientific disciplines that are extremely useful in the way you run a business. And a good example is the fact that randomized controlled trials, as well as in online, are being adopted by businesses all over the place. So, for example, in testing things like changes to store layout, this is something that people approach very scientifically in a lot of organizations these days. They will try to produce a controlled experiment by pair matching stores with similar characteristics, roll out their changes in some fraction of them, and then take a very scientific approach to measuring things like okay, we can track the beacons, the Wi-Fi beacons coming from people's mobile phones as they walk around the store. How have our changes to the layout affected the way that human beings physically navigate through our shop, for example, right? This is not something that I'm working on because The Economist doesn't have shops, but I know someone who is working on something similar to this, So I think this is a bit of a sort of a silent revolution that's going on in business at the moment. Is businesses are saying, oh, well, if we have this data, we should be using it. If we're not, we're falling behind the competition. And they don't have the skills to exploit this. Your traditional business analyst cannot do this stuff, right? So data science is a bit of a vague term. It applies to loads of different jobs out there. And everyone sort of says, well, what is it? Like, what's the main thing? Because this job seems to be that. This job seems to be something different. So I sort of think, my opinion is there's three sort of bits of data science, right? There's knowing some software skills, being able to make stuff happen on data, write the code, do whatever it is that needs to be done, set up a computer, whatever you need. There's the ability to take a scientific approach to the data analysis. So being able to dig deeper, think about things like uncertainties, think about how you can apply different techniques to the data, think about controlled experiment design, things like that. And then there's the sort of the statistics and machine learning angle. You've got people thinking about how you can apply algorithms to large data sets at scale to do things like, well, I mean, you name it. I mean, if you on the way to work, I was looking at my photos from the weekend in my phone, and now the new version of iOS, it pulls all of your friends' faces out, and it says, oh, you can see other trips that you've taken with this group of people, things like this is the kind of thing that's going on up here that I've, I guess, been less involved in recently. So I think, there's people, you can imagine that there's people who do each of these individual things, right? You've got your business analysts, your business intelligence reporting people who analyze data. You've got sort of database admins, software developers they're just software engineers, And you've got your statisticians, and in the very extreme, you've got people doing, things like deep learning research at Google. But your data scientist is someone who sits somewhere broadly in the middle of this triangle, who they're a bit of a jack of all trades, and they know how to solve these problems that, businesses will sort of say, you'll go to a business, you'll work in a business, and they'll say, we just don't really know how to get this done. And your job is to understand enough of these three bits that you can say, well, okay, I don't know what algorithm to use, but I've heard that for this kind of problem, this kind of algorithm might be good. So I can read about that, and I know how to write a bit of code to get that going, and I know enough about the data to sort of present that back. So to sort of be able to tie those things together, I think, you know, I was thinking about where I've been, and I've sort of shuffled around this triangle. I think in physics I was mostly doing some combination of software development and analysis, and at Qubit there was a lot more machine learning involved because we were thinking about things like product recommendations and automatic analysis of text. Whereas at The Economist, I think a lot of it is more about sort of business strategy, so a bit more about sort of the scientific method. So yeah, I think, you know, just to sum what I said there, it's, you know, it's a really new, rapidly changing discipline. I think data science as a phrase only came about 5-6 years ago, really, something like that in any sort of scale. And there's loads of different, I mean, you know, my experience is very specific to the jobs that I've had. If you'd gone and worked in some other industries, you would have had a very different experience. But in London at the moment, there are a lot of jobs. I mean, obviously in places like San Francisco, New York, Boston as well. But in London specifically, there's lots of jobs in online retail, online gaming, technology for the finance industry, finance itself, of course, which is a slightly different ball game. But you know, so different jobs will be very different. You know, like different. Even I, in sort of my one career, have moved around this space a little bit, and different industries are even more different. And I think the key thing at the moment is that at a time where my impression is that permanent jobs are squeezed due to funding in academia, and we have somewhat an oversupply of PhD students in comparison to the number of permanent positions. In industry, it's quite hard to acquire these skills through any standard means. There are starting to be master's courses in data science now, but still, this idea of like research, you know, applying the scientific method, being critical, is something that you mostly learn in research. It's a skill that business people don't have. So for now, there's a huge demand for these skills, and there's not many other ways to get that mixture of skills. Luckily, we happen to be a pool of people who sort of by accident learned all these things, or some combination of these things, and businesses want to pay for people who can do that. So that's the state. So it's a nice industry in that respect currently. I mean, this was I searched Indeed, I typed data scientist in London, just to give you some idea of the diversity of things that are out there, just for my own interest. Yeah, this was the first page. Expedia, obviously a travel company, looking at, so that'll be a job, you know, working on things like dynamic pricing of holidays, for example. You've been on Expedia, you know, it goes up and down like every minute. That'll be the data science team doing that. These guys I've never heard of, but they want someone to create and execute complex data visualizations. Quant analyst for UBS, so, you know, working in finance. Via GoGo, this will be something, again, sort of very product development, and yeah, data scientist, marketing science at Facebook, who knows? But anyway, you know, the point is that there's a real range of stuff out there. So, you know, and then, yeah, like, could you do it? Probably. I think, yeah, one thing that happens in when I've given a talk like this, the one time that I've done this before, is that people said, well, I'm very intimidated when I look at job forms because they seem to have a huge list of requirements, right? And I don't meet all of those requirements. Is it even worth me applying? And I sort of say, well, you know, the reality is that this is like when you offer a job, this is your ideal person. They know all of these things. No one knows all of these things as well as each other, right? So, and especially someone entry level, I wouldn't expect to know all of these things. I think, you know, my benchmark, as I said on the slide, was I would look for someone who knows one of these things well, has a bit of experience in one of the others, and maybe when I interview them, seems like they could learn the third one if I gave them a bit of time and a bit of help or something like that. So it's not about satisfying. I think, you know, it's easy to be intimidated by the spec for a job, and you shouldn't be, basically. 9 times out of 10, they're written by an HR person who doesn't know anything about the person they're hiring, and the person who actually interviews you is basically going to ignore it and just ask you questions about what you did in your PhD and things like that. So I've got a few FAQs to finish up. I think I've got a couple of minutes, couple of minutes. Things that I get asked a lot. Is it boring? No, not to me at least. I mean, you might think it's boring, that's fine. Don't do it in that case. But you know, I mean, for me, I think it's been a lot more varied than my career would have been if I'd stayed in physics, especially if I'd stayed on Atlas. I think you definitely, it doesn't have that sense of, oh, I'm changing the world here. When you work in online retail, you think, oh, great, I might sell some more of something, but it's not quite the same as understanding the universe fundamentally. But on the other hand, the things that you do day to day are interesting. You get an opportunity to work with different techniques, different people, and in different ways, and get new experience. And you do influence. In the case of The Economist, I kind of care about The Economist a little bit, and you get an opportunity to influence an organisation like that in potentially quite a big way. So I don't think it's boring. Do I regret leaving? No. I mean, this is good, isn't it? You said in yours, do I regret? Would I have done anything different? Well, I don't know, but I don't think I have any real regrets. No, I mean, I've enjoyed the experience, definitely. I've not thought about going back particularly, I have to say. And the thing that people always ask me is does it pay well? And the answer is that unless you work in finance, not astronomically, you should expect to get paid a little bit more than you would in a postdoc. But in general, my experience is that the opportunities for progression are much faster than they would be in academia, where you might have to wait quite a while to achieve a permanent position and get above sort of postdoc type salaries. So yeah, that's it. I mean, hopefully that gives you some idea of what is out there in data science, what it is, and so on. Yeah, thanks.
Okay, we'll due back in there in about 3 minutes, so probably time for just 1 or 2 questions.
2 questions actually. Some people think that data science is a fad and it's gonna disappear.
Sure.
What do you think about that?
And what's the other?
I see quite often that people tend to ask for applicants with a PhD in data science or a PhD or a master's in data science or a PhD in deep learning. How much longer do you think that the physicist is gonna have access to these jobs?
So I think, so first of all, is it a fad? I think some people hire data scientists for no reason. I think if you apply for a data science job, you should always ask, why do you need a data scientist? What will the negative impact on your bottom line be if you don't hire a data scientist? And if they can't answer that question, you shouldn't take the job. Because there are some people who, someone senior just went to a conference and they said, and somebody said to them, I've got 10 data scientists, how many have you got? And they were, shit, we need to get some data scientists, otherwise we're going to be in trouble. But I do believe that there is a fundamental benefit to businesses from having people with numerical skills. So I believe that some of these jobs in some industries will get sort of carved off as they realise that people with less skills could do it or something like that. But I believe that it's the fundamental demand is expanding so quickly that it will still exist as the names for it might change as well. It might diverge into 2 separate disciplines, but I think fundamentally the opportunities remain. In terms of the physics aspect, I think it is getting tougher as specialist programs start. I think when I did it, it was easier. I don't think the master's courses in data science have really bitten yet. So I do think there are still opportunities. I don't know how that will progress over the next 5 years. I think it will continue to get gradually tougher, would be my guess. And if you see a job where they're asking for a PhD in deep learning, it's possible they may be so deep learning focused that it's not quite the right thing for you, but yes, I mean that's my general impression. Yeah, sure. One more.
You said working, it's not as kind of meaningful as working in physics and stuff. Are there more meaningful sides to it? Do charities and stuff use data scientists? That would be more.
Yes, Yeah. I mean, there's a huge range of stuff out there, right? I mean, for me, actually, I find working at The Economist kind of meaningful because I like it as a publication. I think if I can somehow sell a load more of it, then that's probably a net benefit for the world. Depending on your political views, you might disagree. But yeah, there's a huge range of stuff out there, right? Actually, speaking of which, I did meet someone last week who works for a consultancy which has a philanthropy program, and she's currently working with charities in Syria to help them collate data about war crimes, for example. So, I mean, in general, if you want to do charity, as you might expect, you can get paid a lot less. But, there is some stuff out there like that. Not so much, but yeah, I mean, it's a really broad area, basically.
Okay, I think we better wrap it up there, but again, hopefully Anna will be around
Yep, yep.
later. So, go on.